So we get all these great ideas. So who thinks they have an answer, a correct answer?
For N or for
First of all, for the first one. So for pattern 43. Pattern 43. How many stars do you think there are? I'm going to check everybody. Well, not everybody. Everybody that thinks they have an answer. You only have one for N? Okay, well, come back then. Well, can you, for pattern 43, see if you can figure out what that is then? Right? You should be able to. All right, Che, what do you think?
I got 87.
87. Okay, not 6, 7. Oh my gosh, did she do that again? Yes, she did. What about over here? Anybody got an answer over here? Anyone? No? Damari? You got 87 also. Okay, what about up in the over here? Anyone? Ooh, it suddenly got quiet. I thought I saw more hands up earlier.
That's probably good. That's for a different one.
Oh, for a different one?
Yeah, for N.
Oh, for N. That could be. So, using your N formula, do you have an answer for this one? No? Okay. All right. Nobody else has an answer?
Like the equation.
No, not yet. No, it's not an equation. What's it called? Expression. Expression. Not an equation. There's not an equals. But it's an expression. Isaiah, you look very puzzled. You had something else, maybe? No? Okay. All right. Che, how did you come up with your answer of 87? I don't know if it's right or not yet. We'll see.
For my expression, I did 3 plus, and in parentheses, it's 2n minus 2 in parentheses.
That's
Okay, hang on. Now, my question was how you got 87. Is this how you got 87?
Yeah, by replacing n with 43.
Okay, so what's N?
You know, the bigger number.
The bigger number. Say more. Say more.
Like the figure.
Oh, the figure number?
Yeah.
So N is equal to the figure number. The figure number. So, okay, so let's try this for figure 1. So if I say 2 times 1, I get 2 minus 2 is 0, and 0 plus 3 gives 3. Okay, so let's say if I put 2 in for N, 2 times 2 is 4, minus 2 is 2, 3 plus 2 is 5, which is how many stars I have. Okay, so that works. 3, let's try. 2 times 3 is 6, minus 2 is 4, 4 plus 3 is 7. That seems to work. So for pattern 43, 2 times 43, 86 minus 2 is 84, plus 3 is 87. Okay, that seems to work. Very good. And that's what he saw. Okay. Damari, you gave 87 also. Did you use that same method? Okay. What did you use, or what did you see that gave you that answer? So he said he took the figure number, multiplied it by 2, and then did what? Add 1. Okay. Figure number times 2, add 1. So here we have a figure number of 1. Take that times 2 and add 1, and we get 3. Figure number times 2, add 1, and we get 5. Okay. That seems to work also. Yeah. So they are both right. Take a look, Che, and you included, take a look at what Che had, and can I simplify that? Can I simplify that expression? And if so, what would it be? Well, what would I get as a result if I simplified that? 2n plus 1. Is that right? Because if you add 3 and you take away 2, that gives you that 1 left, and you have 2n plus 1. Is that not essentially what Damari did? He took 2 times whatever that figure number was and then added 1. Now, let me show you. So I did pretty much what Damari did. Where's this 1 that we're talking about that doesn't change each time? Where is this 1?
The corner.
Yes, the corner star, right? That corner star is in the corner and does not change every single time, right? So that's your plus 1. And then when you say 2 times n, you've got a row over here and a column over here that is, in each case, 2 different lines with 1 each, which is your figure number. So here you have 2 different lines with 2 each. So 2 times 2 plus that 1 in the corner. Here it's 3 times, or not 3 times, 3 plus 3. 3 times 2, which is 6, plus that 1. So this would be 43, because it is figure 43 times 2 plus the star in the corner. Does that make sense? Yeah, nice job. Very nice. Does everybody see that? Okay. All right. Very good. So, 43rd, yes, it is 87 is the answer there. And the pattern would be 2 times n, where n is your figure number, plus 1. That's what it would simplify to. Okay? All right. Turn to page 8 and 9 in your workbooks. Page 8 and 9. Now, here we are going and talking about independent and dependent variables. Independent and dependent variables. Okay. Where would I find an independent variable? If I have a coordinate plane, yeah, it's going to be along the x-axis. So if I draw a coordinate plane like this, your independent variable is whatever you are talking about along the x-axis. Independent. Not the independent axis. Independent variable. Okay? Because whatever your x variable is, it can stand alone. So the dependent variable is going to be along the y-axis, and it's going to be whatever it is you're talking about that happens as a result of your independent variable. Okay? All right. So, yes, we are starting with number 2. Take a look at number 2, and we're going to take a look at number 1. And I would like for you to pair up. So I see we're kind of in pairs, mostly.
Can I work alone? Oh,
Yes, you can work alone if you really, really want to.
Okay.
Okay. I'm guessing those two, you guys maybe can pair up as you are. If you guys want to work together, Che, if you want to work by yourself, or maybe you want to join them, that's up to you. Okay? So, it says work with a neighbor to figure out what the variables are and whether they're independent and dependent. So, Number 2, starting with number 2, the number of buses needed to take different numbers of students on a field trip. So what are the variables that we're talking about first? I'm sorry. I heard lots of stuff there. It was all kind of jarbled though. What's one of the variables? The number of buses. Yes, that's one of the variables. And what's the other variable? Number of students. Excellent. Now, you and your partner need to decide which one's the independent, which one is the dependent. In other words, which one determines the other, or which one doesn't need the other one, but the other one definitely needs the first one in order to happen. I don't want to say too much without giving it away.
I got it.
And if you get that one, go to the next one. The height of the grass in a yard over summer. Actually, let's figure out what the variables are here, because this one is probably one of the hardest ones. It was for me, but maybe you'll get it. Not you? That's good. What's one of the variables there? The height of the grass. And what's the other variable?
Yard.
What about the yard?
Yard over the summer.
What about the yard over the summer?
Like a foot?
Mm,
Like a foot 2 yard.
what were you saying? Not the distance. The height of the grass in a yard over the summer. So if you think of over the summer, what are we talking about? Yeah, time or days. Yes, so time or days over the summer.
What makes sense?
Well, I'll leave it at that and see if you can figure that out. So talk with your partner, your table mate, your frenemy, and see if you can figure out which one is the independent and which one is the dependent variable. Just for you. All right, you said, so you think the day determines how high the grass is going to be.
Yeah, because isn't the height like how tall it is?
Yes.
So it should be on the y-axis. Wait. It should be. Is it not?
Well, that's why that one's a little bit different. And let's see. So the number of buses determines how many students are going on the trip?
Yeah. So it's like should be like bus 1, bus 2.
Yeah.
And then the students are like how many are in each bus?
Well, we're not talking about how many are in each bus. But it's like, okay, I have 7 buses. So 7 buses, is that going to determine how many students I can take? Or do you think the number of students that go on the field trip determine how many buses we need?
So I think like the students are like each students are in different buses. So
Well, they don't have to be.
But like the buses have it has to be a number. So how many students are in the bus? So
Right.
So I have to switch them.
Maybe. We're trying to figure out dependent and independent. So which one determines the other one? Okay. Let's just talk about these first 2. So number 2, number of buses and the number of students. We said those are the 2 variables. Which one is the independent? So it could stand on alone. It would be on the x-axis. Number of students. What do you think? Yeah, number of students or students. Is that the independent? Yes, so that would determine the number of buses. I have every year I do this. I think buses can be spelled with 1 S or 2, but I always just think it's 2. I don't know. Yeah, because if you have 30 students and your bus only holds 27, then you're going to need another bus, okay? But in some places, maybe you don't have enough buses, so you can only take that many students. But most of the time, yes, the number of students determines the buses. Number one, now that we have the variables, this one might be a little bit easier, or maybe not. Which one is the independent here? Time/days is independent. What do we think? Yes? And just because I write it down right away does not mean that's the right answer. It's a good thing we have erasers. So does the time over the summer or the number of days, does that determine the height of the grass? Or is it the height of the grass determines the time or day of the summer? If we don't mow, what's going to happen to the grass? Yeah. So the taller the grass is, how far along are we in the summer? We're further along in the summer. So yes, it is what? Now that I've got myself confused. What determines what? Is it the time or days that determine the height of the grass, or is it the height of the grass determines what the day is?
Okay, I don't either or. Okay, so there's one part, like when you're talking, you're like leaning in.
I know, I was, wasn't I? And then I like talked myself out of it. I was like, wait a minute.
You're like, the height of the day.
The height of the grass. The grass is going to grow. What were you going to say, Sajan? You had a... Yeah. So the height of the grass is going to grow. It really doesn't matter. It doesn't care what day it is. It's growing either way. Okay? So I would tend to say that yes, it is the height of the grass. The height of the grass is going to determine what time or day it is in the summer. Let me check my cheat sheet, because this is kind of one that could go either way. What, you're thinking the other way, aren't you? Speak up, speak up. Okay, so checking my cheat sheet. Checking my cheat sheet, I have it turned around. I have the time or day of the summer, because the longer and the further you are in the summer, the grass is going to be taller, right? I really think this could go either way. But I am probably going to lean more towards the time or the day of the summer. Because, yeah, we're talking about if you do not cut the grass, if it is May 15th and you have not cut the grass is starting to get tall. If you get to July 4th, that grass is still growing and it's going to be keeping growing. So it's the time and the day of the summer that is going to determine the height of the grass. But I could see where this could go a little bit the other way. Because grass just grows independently too. It doesn't care what day it is, right? Okay. I'm going to go with that one. There won't be one like that on the test, I promise. It won't be that vague. All right, so now let's look at 3 and 4, which I think some of you have already done. Has anybody else gone on to 3 and 4? Has anyone not gone on to 3 or 4? Okay. Well, let's first of all, let's come up with our variables. The weight of your dog and the reading on the scale. Well, that one's pretty weight of dog, and reading on the scale. So which one is the independent? Weight of the dog, yes. The weight of the dog determines the reading on the scale. Okay? Just think, if somebody else could figure that out for humans the other way, like if the reading on the scale would determine your weight, that'd be like, you'd be a millionaire.
Yeah, it's like the machine unborn, you like stand on top of it and it's like.
Yeah. All right, so the amount of time you spend in an airplane and the distance between your departure and your destination. So one variable would be time in an airplane, and the other one, distance between departure. So think quickly, which one is the independent? Which one is the independent? The distance or the time? Distance, yes. So if you are here in Indianapolis and you go to Columbus, Ohio, you're not going to be on the airplane as long. So distance between departure than if you went to Los Angeles from Indianapolis. And dependent is time in an airplane. Okay? So with you and your table mates, compadre, person, see if you can finish the rest of these on page 8 and 9. Which is the independent variable? Which is the dependent variable? And we'll see if we can go through these answers before we get done with class. So I'm going to give you about 7-ish more minutes. See if you can figure out independent versus dependent on the recording. So think of it as cause and effect. One causes the other to happen, or one determines the other. So for number 5, the number of times you dip a wick in hot wax and the diameter of the homemade candle. What's the independent? Yes, the number of times you dip the candle. The more times you dip it, the longer the diameter is going to be. Okay? Everybody agree with that one? Okay. Number 6, the amount of money you owe at the library and the number of days your book is overdue. What's the independent? The number of days your book is overdue. Dependent is how much money you owe. You don't owe money until it's overdue, right? Good. How about number 7, the number of homework assignments you haven't turned in and your grade in math? Number of homework you didn't turn in determines your grade. That's pretty much true. All right, number 8. This is always a good one. Sometimes people go back and forth. The temperature of a carton of milk and the length of time it has been out of the refrigerator. What's the independent?
Out the fridge.
The length of time it's been sitting out determines its temperature, because the longer it's been sitting out, the warmer it's going to get. Does that make sense? Okay. Number 9, the weight suspended from a rubber band and the length of the rubber band. What is the independent? The weight or the length? The independent? The weight, yes. The longer or the bigger the weight is, the heavier it is, that rubber band is going to stretch even more, right? Number 10, the diameter of a pizza and its cost. What's the independent?
The diameter.
Diameter of the pizza determines the cost. Although, that one could go back and forth. If you talk to pizza people, they might not care what the diameter is. They're saying, here's the cost, here's the diameter, But I think for the most part, diameter does determine the cost. And the last one, number of cars on the freeway, the level of exhaust. What's the independent?
Number of cars on the freeway.
Number of cars, yes. The more cars you have, the more exhaust you're going to have. Number 10, diameter determines the pizza cost.
So the diameter is independent.
Correct. Yes. Any question about those? All right.
What about the
Number 11, number of cars on a freeway and the level of exhaust. What do you think?
I don't know.
Well, does exhaust determine how many cars are on the freeway? Or do the cars determine how much exhaust? Yes. Yep. All right. So, still no homework, but you could start on it. I'll see you guys tomorrow. Have a great rest of your day.
Wait, so what's the word? Like you said, there's no homework, but
No homework officially, but you can always